I will first be showing you how to find the area of a triangle to if the equation area equals half times base times height is true, and I'll show you in three different scenarios. First, the area is the number of 1 by 1 squares in a closed figure. So they don't have to be like the 1 by 1 squares don't need to be touching each other, but they do, that is how you count up how many areas, or what the area is in the triangle by counting how many 1 by 1, but like 1 by 1 unit squares are in the figure. The first way to find out if your area times half times base times height works is if the triangle, the height is on the inside, as you can see right here with the dotted red line going down the middle of the triangle. What I did is the red shape is the triangle that I started out with, and then I copied and rotated the triangle to the outside portions of it, which is shown in the green dashed line. Right here we have x, a number, an x unit, and then a y unit, and then I have the height here and the height here. These heights will be the same. Just this one's going down the middle and this one's on the outside, which helps us do the math a little more. In order to figure out the equation for this one, you do half times x times h, which you can see here, because this is half of the triangle, and then half times y times h, which would be this triangle. And this portion of it, it would actually be this whole portion, but we're putting half in there because we're only using half this space in here rather than this space in here, the full thing, so that's why it receives the half. From that, the b of the base of the equation we get from adding x and y together, because that completes the whole base of the triangle. And from there we can determine that half times base times height actually does work for using this as a height on the inside. The second triangle is a right triangle. In order to do this one, I took the triangle and I reflected it, which is shown here by the green dashed lines. I called the bottom the base and this side over here the height. And since we are only, again, using half of the rectangle, we can put the half in front of the base times height, because that's how you find out what a rectangle is you times the base times the height. But since we're only doing half of it, it can be half times base times height. The final triangle is an obtuse triangle. This one is a little different compared to the other ones and involves a little more math. But what I did is the red is the original triangle, and then I did some rotating and whatnot to build a rectangle around it, shown by the dashed green lines. I called this little portion right here x, and I called the next, the base of the triangle, the base. And then I gave this the height. What we do first is we take the big triangle and we do half times x plus b times h. And then we take the small triangle, just right here, and we did half times h times x. And I subtracted the two big triangle minus the small triangle to get half x plus b times h minus half x plus h, half x plus h, and then I distributed this portion right here. So then I got half x plus x times h plus half b times h minus half h times x, and since these two will cancel each other out, leaving you with the area that is half times base times height.